All right, guys. So this should be our last Excel video of the semester. If you wonder why I'm always looking away from the cameras, because I have multiple screens set up here. My camera's over here on my laptop, so I'm looking on a big screen over here. Anyway, all right. So what we are looking at this time is regression. Now you have a copy of this worksheet in Georgia View. Okay. And what we're going to look at, the gist of what we're doing here, which you should know, because hopefully, like I said, you've been doing you're doing the Excel videos after you've watched the class video. But what we're going to do here is look at the relationship between the sales calls and the copier sold. We're going to see how strong that relationship is first of all, and then we're going to quantify that relationship. Okay, so this is stuff, like I said in my course video. This is stuff just like you did in algebra, okay? We're just talking about lines here in the line formula, all right? That's all we're talking about. So we're going to come up with two numbers to explain that line, the rise and the run, and we're going to plug in our variable, apply it to that rise and the run, and get an answer, all right? But we're going to do it using the data package again, all right? So if you don't have the data package, so first off, let's go to data. And if we look over here to the far right, we have this group within data called analysis, and we have the data analysis pack in the analysis group. Okay, if you don't have that, please look back to part 1 of this chapter's Excel video, and I'll show you how to do it. Or it's all over the videos. I do it multiple times in the classes, so you got to remember how to do this. Okay, so all right, so we have sales calls and copiers sold, and then we have the name of the sales rep. But these are the two we want to explore the relationship between these two. Okay, so sales called, copier sold. Which is the dependent? Which is the independent? Are sales calls dependent on the number of copiers sold? I.e., you sell a certain number of copiers, and that determines how many sales calls you make? I don't think so. It's probably the other way around, isn't it? The number of sales calls you make is going to determine how many copiers you sell, isn't it? Okay, so let's get Brian Verost here. He's doing pretty well, yeah. He's batting almost a little 45%, something like that. He's made almost 100 calls. He sold about 41 copiers. Look at this guy, Carlos Ramirez, the next guy. He's made 40 calls, and he sold 41 copiers, as many as Brian Verost has, in less than half the number of calls. Okay, so it looks like we're kind of all over the place. Well, you know what? Before we even start this, let's just get an bird's eye view of what's going on here, okay? An eyeball on it. So how do we do that? Well, let's build a scatter plot. Okay, so let's go insert, let's go scatter plot, and let's go scatter. Oh, my bad. You know what you have to do is highlight your data first with your independent variable on the left side. Okay, so let's highlight our data, insert, scatter plot, and there we go. Now let's click on one of the dots, right click on one of the dots, and we're going to go add a trend line. And now we're going to we're going to go here and we're going to format our trend line, if it will let us. Here we go, over here on the right. Okay, so now when you have format trend line set up over here on the right, okay, you want to drop down and you want to display the equation on the chart. And does everybody see what just popped up here? Okay, we got our equation right here now, don't we? Okay, so y equals 0.2606x plus 1998. What's 1998? It's our y-intercept. What's 0.2606 is our slope, okay? All right, very good. So for every one it goes up, it moves over 0.2606, okay? And we start right here. If we were to draw this line all the way down, this would intercept right here at 19.98, almost right at 20, wouldn't it? It would intercept the y-axis. All right, very good. So let's really figure out what's going on here. It looks like there's a relationship, huh? A decently strong positive relationship. I'm going to slide this under here, because we're about to pop up a lot of information on this screen, okay? All right, so let's run the regression analysis on this. So let's go back to, let's go to data, okay? And let's go to data analysis. Go ahead and click on it. And now let's go to regression. Does everybody see that? Regression. Click OK. And it's going to start asking us questions. So input our Y range. What's our dependent variable? The dependent variable would be what? Copiers sold, wouldn't it? All right. What would our X range be? The independent variable. What would be sales calls, wouldn't it be? That's independent of the number of copiers sold. The number of copiers sold is dependent upon the number of sales calls you make. We think. And it looks like that's the case, yeah? Okay, so we leave confidence level 95. We don't need that. We did include the labels. Let's leave that there. We can check that if we want, but it doesn't really matter for these purposes. Okay, so our output range, let's just pop this sucker out at I2. Okay, so output options, that's where we want to put it. Let's leave these because we will have an indication of the residuals. And actually, let's click residuals and let's leave the rest, okay? All right, and then let's click OK. And look what we get, a whole bunch of information, huh? I'm going to delete this column just to bring it over a little bit so we have a little more room. And I'm going to highlight these and I'm going to double space it. And hopefully you can see all this, but it doesn't really matter because definitely everything that we need you can see. So let me delete this one as well. All right, so the multiple R. I bet I can figure this out another way. Equals CORRELL. And I'm going to go boom, comma, copier sold. I'm going to close it and hit enter. And look what I got. So I just ran that Corel formula we looked at it in part 1, and I got the same answer as this multiple R. So what is this multiple R? It's the R. It's the normal R. It's the correlation coefficient. It's Pearson's R. That's all it is. Okay, R squared is called the coefficient of determination, and it explains how much of the error of the R of the Y can be explained by X. Okay. So coefficient of determination, we talk about it in class, look it up a little bit more, but again, you want this higher. The higher, the better. But literally all it is this squared, right? Okay. Adjusted R squared, you use this when you have more than one independent variable. The standard error, please do not get confused. This is not the same standard error that we've been using all semester, okay, or at least half the semester. All right, so just disregard it on here. With all this information, we're only using a little bit. So I know it looks intimidating, but don't sweat it. Okay, so observations, 15. That's all we're talking about here. Okay, I highlight this. How many do I have? 15, count. Excuse me, 15. Okay, so ANOVA analysis, we did not do this F test, the significance of the F. There is something that should look a little familiar here, though. Residual is 13. Degrees of freedom, for the regression, there's 1. That looks a little different, but the reason is because we have 2 variables, okay? So that's why this residual is 13 instead of 14, okay? Don't worry about this. We don't need this. Here's what you need. Go down here and look at these coefficients, okay? So this lists the coefficients that you need in your formula. So the intercept, the y-intercept, is 1998. Does everybody see that? Very good. It is exactly what it states right there, isn't it? Boom. And then this one is the this is your slope, is your m, right? Your mx plus b, that's your m. Oops, that's not what I meant to do. Let's do this. Boom, that one. Okay? So do you see how these two relate? Okay, they're plugged into your formula right there, aren't they? That we looked at earlier when we inserted the formula into the trend line. Okay, again, this is not the standard error. We've been talking about your p-values for your independent variable, your intercept. It's, I guess it does. I guess we did test it to the 95, so we would know. Well, no, don't worry about the rest of this. To tell you the truth, your t-stat, you can use all this, but it gets confusing. So to use any of this other stuff, please just run the other ways I've showed you with your in the other videos from chapter 10 with your t-stat and all of this stuff. Okay. Your residuals. This is just how far each one of these variables is off the line. Okay. So for instance, predicted copiers sold. Okay, so this is where it would be if it fell right on the line, the number of copiers this person sold. Okay, this is how far off it actually is from that. For instance, who's number one? Brian Verrast. Okay, he's made 96 calls. So at 96 calls, he would have been expected to sell a 45 copiers, but he actually sold 41. 45 minus the actual, which is 41, is -4, and that's your residual. Okay, so again, just like we talked about in class, each one of these is a residual, and that best fitting line right here that is represented by this formula minimizes the sum of each of these residuals. Okay, and it's explained by your coefficient of determination. All right? Okay, but just look at the videos if you don't understand what I'm talking about, and I explained it in there. Now, there is one more thing I wanted to point out about this. It's always good to run the, it's always good to do the, I'm slouching for my video. I just get talking and I stop paying attention. But anyway, it's always good to run this scatter plot first, because your multiple R right here will not give you a negative sign. So if this had been a negative 0.6 relationship, this line would be the same slope, just the other way, right? And you might not have picked up on that, all right? So that's why it's always good to make the scatter plot, because it's not going to give you the negative here. All right. So big things to remember from this chart. This one, that's really about it. And this one and this one. Those are the main takeaways from just a straight regression like we're doing, okay? This is the sum of squares. Oh man, I forgot what this stands for, but it's the sum of squares divided by the degrees of freedom. This is your F test we did not do. We skipped that chapter, significance F. Okay, so anyway, all interesting stuff. If you want, email me if you want to know any more. But we're going to stop here. Again, this is the last video for the semester, so you should have everything that you need at this point. So you have, from this point, from today, you have about 1 week to finish everything up. Don't forget about your extra credit assignment if you want to do it. The assignment's on Georgeview, has been for a while. And yeah, just let me know. Email me if you have any questions about anything. And good luck with everything. And I will talk to you guys later. All right.